Everyone. Today we will discuss about agent discovery. Okay. From many days we are discussing about mobile IP, how packet moves from one place to another place, and even after moving from one place to another place, how mobile device still maintains the communication. How mobile IP maintains this communication. We are discussing about that. In last classes we have discussed about IP packet delivery, where correspondent node sends packet to mobile node, and also mobile node sends packet to the correspondent node. Okay. So in that IP packet delivery we have discussed that if a mobile node is not in home network, if mobile node is residing in foreign network, still it gets packet, because foreign agent is one which helps the mobile node to receive the packets. Okay. So MN mobile node will receive all the services from foreign agent, like it receive all services when it is in home network. Okay. So what about this agent discovery? What is this actually? See, once if mobile node moves out of the home network, then it has to discover where foreign agent is there. Okay. How mobile node knows? So it gives the following information. We will read out this. A mobile node uses a method known as agent discovery to determine this information. What is that means? When the node has moved from one network to another, means if mobile node is in home network, then home agent will provide all the services to the mobile node. If node has moved from one network to another network, means from home network to foreign network, then when it is moved from home network to foreign network, that information have to be noted by the home agent. So how that information is noted, that is done by agent discovery. And also whether the network is in the home or an foreign network, means this information also have to be stored in the home agent, because home agent is the one to send the information to either COA or to other mobile nodes or to the internet, that where actually mobile node is staying. So whether the network is in home network or foreign network, mobile node, where mobile node is staying now, that information is also taken from agent discovery. And next, the third one is, what is a foreign agent care of address offered by each foreign agent on that network? So as we have discussed, each and every foreign network will be having a foreign agent, and foreign agent will be having a care of address, COA. Okay. So this which foreign agent is having which care of address, and what is the work of care of address, how it will get the information about the mobile node, whether it is staying in the home network or whether it is staying in the foreign network, or when the mobile node has moved from home network to foreign network or from foreign network to home network. All these information will be stored under care of address, which is under foreign agent and which is under foreign network. All these informations will be given by the agent discovery. So this is how agent discovery is used to know whether mobile to know about the location of the mobile node. So normally mobility agents transmit agent advertisements to advertise their services on the network. In the absence of agent advertisement, a mobile node can solicit advertisements. This is known as agent solicitation. So under this agent discovery, we have two things, that is agent advertisements and agent solicitation. Okay. So what are these agent advertisements? What are these agent solicitations under agent discovery? That will be discussed now. Agent advertisement. In agent advertisement, what happens means, whenever a mobile node moves out of the home network, whenever it want to go to the foreign network, that time soon after moving from the home network, all remaining foreign agents will advertise their presence. Means there will be so many foreign networks. Once moving out of home network means everything will become foreign network. So all these foreign networks, all these foreign agents will advertise their presence that we are here and I will offer these many services to you. Like they advertise their presence to the mobile node. You can come and stay in my network. I will provide all the services to you like you receive the services in your home network. Like that, they will advertise their presence to the mobile node. And these messages, advertisement messages, can be seen as a broadcast into the subnet. So, to the physical subnet of the mobile node, all these advertisements will be received. And for these advertisements, it uses ICMP messages, Internet Control Message Protocol. This is called as ICMP messages. According to the RFC 1256, these ICMP messages are used by the foreign networks to advertise their presence to the mobile node. And routers in the fixed network implementing this standard also advertise their routing services periodically to the attached links. Even fixed networks will also uses this type of agent advertisements to tell the mobile node about the services offered by foreign networks. Okay. In case if mobile node does not receive any message, means mobile node now moved out of home network, but it did not receive any message from foreign networks, any advertisements from a foreign network. Then what mobile node will do? Mobile node itself will advertise its presence to all foreign agents that I am now came out of my home network and I want some foreign agent or foreign network to do my work. Like this, it will mobile node will solicit its presence to all the foreign networks. That is nothing but agent solicitation. Okay, we will discuss agent solicitation separately. Okay, so for now, so all other foreign networks, all other foreign agents will advertise their presence by using ICMP packet. ICMP is nothing but Internet Control Message Protocol. Okay, so there is a figure for this, a diagram is there for this. As I already told you, total mobile computing subject will be having so many diagrams, means for one topic one diagram will be there. So here also for this agent advertisement we will be having a diagram. Before that, this IP destination address is always set to 224.0.0.1 if it is a used for multicast. If it is a broadcast address, then 255.255.255.255. Okay. If it is multicast, then 224.0.0.1. Okay. This is the diagram for agent advertisement. So in this diagram we have some parts like type, code, checksum, addresses, address size, lifetime, router address 1, preference level 1, router address true, preference level 2, and type, length, sequence number, registration lifetime. And these are few letters here like R, B, H, F, M, G, V. You can also will have R, T in other diagrams. And reserved, care of address 1, care of address 2. Okay. In this diagram, this total diagram is divided into two parts. The first part is an ICMP part. ICMP is nothing but Internet Control Message Protocol. That is the ICMP packet. And the second part is for just mobility extension. Okay, so this total diagram is divided into two parts. The first one is ICMP packet and the second one is used for mobility extension. Okay, so in this diagram whatever the fields we have seen now we will discuss about. the fields. So first in the diagram, what is type is set to 9. Where in all ICMP packets, type is always set to 9. Code. This code is either set to 0 or it can be 16. And these two will be having a separate meaning, that if a code is set to 0, it is nothing but agent also routes traffic from non-mobile nodes. Non-mobile nodes means fixed network. Means this mobility means nothing but a mobile device can send messages to either mobile device or to a fixed network. Mobility is not mobility means you cannot say that it will only send packets to mobile devices only. It can send packets to mobile device and also to the fixed network. Okay. So code is set to 0 if agent routes traffic from non-mobile nodes also. If from fixed network, if you are getting messages to the mobile device, if you are getting packets from fixed network to the mobile node, then the code is set to 0. If the code is set to 16, it is nothing but it will not route any packets other than the mobile traffic. Means fixed network is not there here. From fixed network, no packet is received. Only from mobile device packets will be received. Okay. If it is set to 0, from fixed network to mobile devices communication is there. If it is set to 16, then only between mobile devices communication will goes on. Okay. Checksum. Next one is checksum. In the diagram, the right part, checksum is there. Checksum means it is a 16-bit ones complement of the ones complement. And it is based on the sum of ICMP packet or IRDP message packet. Okay. So it is always the 16 bits ones complement of the ones complement, which is the sum of ICMP packet message. And this ICMP packet is the upper part of the diagram, not the mobility extension. And the next one is addresses. The left side, addresses. Addresses means the number of router addresses advertised in these messages. So as I told you, once mobile network moves out of the foreign home network, so every foreign agent will advertise their presence. So here addresses means how many router addresses are advertised in this message. That will be stored in the addresses. And the next one is address size. In the middle part, address size. Address size means the number of 32-bit words of information for each router address. The number of router 32-bit words of information per each router address. So for every ICMP packet, for every agent advertisement message, there will be some size. Okay, here the size should be 32-bit words only. For each and every router address, the address size would be 32-bit words. Okay, and the next one is lifetime. In the diagram, it is there in right part. Okay, lifetime. So lifetime means the maximum number of seconds that the router address may be considered valid. So here every foreign agent or every foreign network will advertise their presence when mobile node comes out of the home network. So once they advertise their presence, how many seconds it has to be valid. So that information will be stored in lifetime. Means once if they advertise their presence, it will not stay forever. Only for some time their advertisement will be on the router. Not every time. So how many seconds that advertisement is valid, that will be stored in the lifetime. And the next one is router address means the sending router's IP address on the ith interface from which message is sent. The router path of the uh, address where the ICMP message has come or where the advertisement have seen, that is nothing but the router address. And preference level means the preferability of each router address. For each and every address, it helps a node to choose the router. So that is the most great thing to get a new node. So it can choose the router based upon the preference level, based on the router ith interface. Okay, this is a ICMP packet. We have discussed about the first part of the diagram, that is ICMP packet. And the second part of the diagram is nothing but mobility extension. In this mobility extension, again we will be having some fields like type, length, sequence number, registration lifetime, and few letters R, B, H, F, M, G, V. You may also get R and T in other diagrams. And other field is reserved, care of address 1, care of address 2. Okay. This is for mobility extension. Here, type. Type is set to 16 here. Here also always type is set to 16, which is nothing but mobility advertisement extension. Okay. Length. Length is nothing but 6 plus 4 into number of addresses. What is the length of the address is nothing but, so that every foreign agent or every foreign network will advertise their presence with the with some address size, length of the address, that is nothing, that address is 6 plus 4 into number of addresses. Okay. And sequence number is nothing but total number of advertisements sent since the initialization, from starting. How many advertisements have given by the foreign agent? Okay, those numbers, sequence number will store the count of the agent advertisement messages from starting. Okay, is registration lifetime. Registration lifetime means maximum lifetime in the seconds a node can request during registration. During the registration time, how many times a node will request, that information will be stored in registration lifetime. How many times a node can send a request, that will be stored in the registration. Okay. And here some bits are there in the slide. I did not mention. I will explain now. These bits are, the first bit is R. This R bit shows if a registration with the agent is required even when using a co-located COA at the MN. We have discussed about the foreign agent COA and co-located COA. Co-located COA means within the home network. Okay. So here R bit shows that if a registration with this agent is required even when it is having a co-located COA at the mobile node, even after staying in the home network, if a node still wanted to if a node still wanted to get the advertisements, then this R bit will be set. Okay. And the next one is B bit. If the B bit is set to B when if the agent is currently too busy to accept new registration, okay, then it can set to the B bit. If agent is currently too busy to accept new registrations, then it can be set to B. Okay. And the following two bits, H and F, these two bits are used to denote if the agent offering a services as a home agent or as a foreign agent. If it is offering services as a home agent, then H bit is set. If an agent offering services as a foreign agent, then it is set to F on the link where the advertisement has been set. Okay. And the next one is MG. MG, and also sometimes you will be getting I. Okay. So these bits represents which type of or which method of encapsulation is used in these advertisements. We have some three types of encapsulation methods which we will be discuss in next classes. These three encapsulations are IP encapsulation, minimal routing encapsulation, and generic routing encapsulation. These are the three types of encapsulations are there. Which type of encapsulation is used? That will be denoted by M, G or IP. Okay. And lastly, V bit. This V bit is specified to use header compression. Okay, just for header compression, this V bit is used. I already told you in some diagrams we will be having two more bits like R and T. Here in this diagram, that R and T is not mentioned, but in some diagrams these two bits will be there. So I will give you the explanation of those two bits also. If the R bit is set on the field, it is nothing but bit position is set to 0 and it should be supported or ignored. Okay. If R bit is set, then it is nothing but it should be ignored by the bit position. If T bit is set, then it is nothing but it is using a reverse tunneling method which is supported by foreign agent. Reverse tunneling means the packet is set or packet is sent back to the foreign agent again. That is nothing but reverse tunneling. Tunneling is nothing but when packet is moved from one place to another place by encapsulating. Then that encapsulated packet is tunneled from one place to another place. Okay. So from source to the destination, if a packet is moving, then that is called as tunneling. Okay. After going to the destination, if again packet is coming back from destination to the source, then it is nothing but reverse tunneling. Okay. This is about agent advertisement. Okay. This is how all the foreign agents will advertise their presence whenever mobile node moves out of the home network. So now by looking at all these ICMP packets, by looking at all these advertisements from all the foreign agents, mobile node can now choose the best one to stay in that location. So it is the choice of the mobile node where it wanted to stay and take the services, and these foreign agents will offer all type of services like a mobile node receives in the home network. What are the types of services they offer? All the foreign agents, they mention in their advertisement packet. Nothing but this ICMP packet. So all these advertisements will be having ICMP packet and also mobility extension. Two parts in the advertisement. This is how all the foreign agents will advertise their presence to help the mobile node whenever it moved out of the home network. Okay.